Okay.
Okay.
So,
So more to video too.
oh, I see.
Right. Okay.
Are we live now?
এবার হব লাগে
Okay.
yes
তোমার account? Okay, I'm live.
yes there was one more option যে
Okay.
লাইভ আমি
Okay.
জানি
Yes. All right. All
There
right.
was
Live now?
yes এবার হব লাগে
Okay.
yes
তোমার account? Okay, I'm live. I think তোমাৰ ভিডিও ক'বাত আৰু on হৈ আছে।
sorry
তোমাৰ ভিডিও ক'বাত on হৈ আছে। I can hear my voice.
Oh, অলপমান
Live now?
এবার হব লাগে এতিয়া শুনি আছা নেকি কৰবাত
Yes.
এতিয়া নাই নেকি
Yeah, এতিয়া নাই।
oh,
Okay, so we can start.
sure.
তো সকলোকে নমস্কাৰ জনাই আজি আমাৰ ক্লাইমেট ডায়লগ ৱে ফৰৱাৰ্ড সিৰিজৰ তৃতীয় বৰ্ষৰ ষষ্ঠম খণ্ডলৈ স্বাগতম জনাইছো আৰু অলপমান টেকনিকেল ডিফিকাল্টি হ'ল বিকজ অফ ডেট আমি অকণমান দেৰিকে ষ্টাৰ্ট কৰিবলগীয়া হ'ল বাট এনিৱেজ চ' আমাৰ মাজত আজি আকৌ আছে প্ৰফেচাৰ বি.এন. গোস্বামী ছাৰ ৱেলকাম
Thank you.
চ' ছাৰক চিনাকি কৰাই দিয়াৰ প্ৰয়োজন ইমান নাই তথাপি আমাৰ ফৰ্মেলিটিৰ খাতিৰত আমি ছাৰৰ চমু হেৰি এটা ইন্ট্ৰডাকশ্যন প্ৰফেচাৰ বি.এন. গোস্বামী was born at Patbaushi, Barpeta, and he did his schooling in Barpeta Vidyapith School, and he's an alumnus of Cotton College and Guwahati University. He secured sixth position in his pre-university examination, and Professor Goswami completed his Ph.D. in 1976 from the PRL Ahmedabad in nonlinear physics, and then he joined Professor Jule Charney at MIT for his postdoctoral research. In 1983, he returned to India and offered his service at the institutions like IIT Delhi, IISc, etc. And in 2006, he became the director of the Indian Institute of Tropical Meteorology, Pune, and made it a state-of-the-art institute in climate research. He changed the course of Indian monsoon research by heading the Monsoon Mission Project of the Ministry of Earth Sciences. Currently, he is involved with Cotton College as an SERB Distinguished Fellow. His research focuses on various dynamical aspects and predictability of the Indian monsoon. Professor Goswami is the recipient of several international and national awards, including the 𝗪𝗪𝗏 Bhatnagar Prize. And he likes to spend his leisure time reading fiction thrillers. So, এইটো একেবাৰে চমু introduction, ছাৰৰ। So, it's always nice to talk to BNG. আমি যিসকল ছাৰৰ লগত ক্লোজ তেওঁলোকে জানে যে is more popular as BNG among the community. So, আজি আমাৰ যিটো টাইটেল Heatwave, আমি সকলোৱে যোৱা কিছুদিনত বিশেষকৈ মে' মাহৰ আৰম্ভণিৰ ফালে শেষৰ ফালে বৰষুণৰ মাজে মাজে আমি বহুতেই বেছি গৰম পাই আছো গৰমৰ এই হিটৱেভ বা এক্সট্ৰিম গৰমৰ দিন এই বিষয়ে আমি ছাৰৰ লগত কথা পাতিম আৰু ছাৰ আৰম্ভণিতে আপোনাৰ পৰা দুআষাৰ
Thank you, Vidyut. It's always a pleasure to be here with you guys. So how do we start? তুমি কিবা হেৰি কৰিবা নে মই
there is not
no format.
such format you can start, but where we can start is আমাৰ মে মাহত যিটো হিটৱেভৰ কথা আমি ফোনতো পাতিছো আগতে so recently like May first week last week and probably towards first week May প্ৰথম সপ্তাহ শেষৰ সপ্তাহ এনেকুৱা সময়ত গুৱাহাটীৰ temperature in higher 30s 37 38 39 even 40 cross কৰিছিলে so এনেকুৱা ধৰণৰ temperature we had seen যিটো IMDৰ ৰেকৰ্ডৰ পৰা আমি জানো যে it was in 1960 I think in 1960 মে'ৰ 1 তাৰিখ নে কিবা 40 বেছি হৈছিলে so how do we see it do we see is it like a very extreme event happening just once in like several decades or do we see any trend or as somebody who has lived or spent his childhood in Assam in 1960s probably not childhood but yeah youth and how do you see it how do you feel it now and as in your day-to-day life as well as a scientist how do you see this
Yeah, actually, that is an interesting question. I have been feeling it that of course we know that the extreme events are increasing everywhere, the heat extremes as well as heat spells, as well as rainfall, daily rainfall extremes are all increasing everywhere, especially in India. We know that, but about heat spells and whether the heat spells have increased or heat intensities have increased. There is not enough studies, and especially in the northeast region, we are more affected by what we call humid heat stress. Because we are in monsoon region, our mean rainfall is high, the mean humidity is always high. So whenever there is a rain break period, we have a lot of humidity, and the temperature, if it is just exceeds 35 or 36, you have pretty high humid stress already. So that is, but unfortunately, I think that recognition of the effect of humid heat stress and its effect on the human health and productivity is not well recognized or well popularized in our system. The IMD has a humid heat index. That heat index contains humidity, but they never really publicize it properly. And as a result, what happens is whenever they talk about heat stress, heat spell, then it is essentially related to dry heats. Basically, in the western part of India, it is mostly dry heat that prevails, or more of the dry heat. But in the eastern part, we are more humid, and therefore the humid heat stress is much more important. Unfortunately, it has not been properly evaluated or studied. Personally, I have been feeling that for a long time because last I came back to Assam in 2017. So since 18 itself was very, very hot and humid and very, very stressful. And there are long periods where you could not really tolerate so much, you sweat so much, you cannot get out. And even inside the house, a little bit of work sweats you. So I was feeling that, and there is a perception. And so maybe 1 year it is a little less, but another year it is more. But every year there are many days where this heat spell, the heat effect has been heat stress. Actually, personally, I felt quite high. And this, compared to what probably when I was young and living in a rural area, partly because rural area, but partly because it was different. The climate was different, and I don't think we felt this bad. I don't remember feeling this bad. So there is a perception that it was building up. I think, there is some basis to think that it is increasing. Because if you look at the mean temperature itself in this region has increased by almost about 2 degrees, 1.7 degrees or something, mean temperature So by 2 degrees increase is already 14% increase in the humidity is already there. Okay, so therefore you can always think that, and our mean humidity itself was already higher. So that 14% increase of humidity could could surely make the the local greenhouse effect also much more. Therefore, it is affecting the night temperatures to go up, and therefore the discomfort level has, earlier the night temperature will go down, at least you will feel better. But today, I think the discomfort level has increased because night temperatures are also increasing faster than even the daytime temperatures. So as a result, the discomfort level has increased tremendously. But the question is, how do you quantify it? Is it possible to quantify and see whether it actually has increased? So this was an interesting. I was not very serious, but for many years or so we were thinking that we will do something. But I think recently there was a couple of students, some high school students came to do intern with me, and they were very. I mean, they had no idea what to do or whatever. So I think, and one of my students, 𝗲𝗏, he was actually looking at some of the heat-related extremes. So I asked the young interns to look at the simple as an example. Let us try to see what is happening to our heat extremes in this. The number of extreme heat days, has it gone up or gone down in this region, or is there some sort of a trend? And if that trend is there, whether that is high. Whether that is very linear trend or it is non-linear trend or whatever. So so they started working. They and 𝗏𝗏 was actually collecting some data, and so we got some of the we downloaded some of the ERA data and started looking at simply the wet bulb temperature. Initially we thought we'll simply look at wet bulb temperature and see wet bulb temperature maximum, how it has changed. So that actually gave us some very interesting results. So let me show you a couple of pictures, and then we can come back to the where is my, how do I share my screen? I think this is the correct. I think it should work. Can you see it?
Yes, I can.
Okay. So how do I make this?
It's a down. Yes.
Down?
Yes. That's the yes.
That's
the next one.
No.
You can. Sir, apni review kakhot view buli ase je tate slideshow দিব পাৰে.
Code viewers. আহিছে ঠিক আছে. So so to do that, we have to actually understand what is this humid heat stress. So just let me go through a little bit of this definition of how do we define humid heat stress. Actually, when we started, we did not really go through any of these, but later on, I started learning a little bit more, and then so one of the way to define is something called humidex. So humidex is humidex. Oh, sorry. How do I go back?
Back arrow. আপনার keyboard যেটা arrow আছে
left arrow to press
left arrow to press কৰিলো কিন্তু এটা শব্দহে হৈছে এইটো যোৱা নাইচোন.
Okay.
Then you can just put escape.
Escape.
I can see a arrow in the left bottom corner of your presentation.
Yes. Okay. Oh, error to আছে, okay.
এই
Okay,
জুমৰ
okay.
কন্ট্ৰল বিলাকৰ কাৰণে এইবিলাক
Okay, so what is humidex is an index where you have the air temperature, but you also have a temperature that it like feel like temperature. Now, why do you have a feel like temperature? When you have more humidity, you have less ability to evaporate, and therefore your body feels like a higher temperature. It is just the reverse of what extratropics people have something called wind chill factor. You remember?
Yes.
You guys have lived in Canada and all that. So wind chill factor is in a colder climate. If your temperature is cool and there is more wind, you evaporate more. So evaporation more means you will cool down further. So body will feel colder. So that is why there is you can calculate that. There is a formula which will tell you that, okay, if there is a air temperature is 0 degree, but wind speed is 20 meters per second, you will feel like minus 10 degrees or something like that. So so that is the wind chill factor. So similarly in tropics, I think we should have a similar factor, and that is the humidex. And that is, so this factor depends on evaporation, so therefore it factors on wet bulb temperature and or dew point temperature. And so it is, that part is a bit non-linear. So but still, so you can calculate that, and that means so if you, and that is shown here. So if your air temperature is like 30 degrees, and your these are curves for different ranges of humidity, relative humidity. Okay, so if your relative humidity is 70%, 70% is this is the red curve, red curve. So and your temperature is 34, you will feel like 50 degrees.
Yes.
So that is how you feel. So, and in our place, the 32 degrees and 70-80% humidity is very common. And that is like, you always feel like 50 degrees. And 50 degrees is actually pretty bad. And you cannot evaporate, you cannot lose it. And that is the point. So this is one way. And people have studied that, okay, if it is between this humidex factor scale, if we calculate in Celsius, it can sometimes, by the way, this scale of humidex was originally defined by the Canadian Met agency. Because they somehow operationally use it. Actually, they don't need it. I don't know why they started. Actually, tropical people need it more. And tropical people are not popularizing this is enough. And so I'm actually surprised. But that is how they have started. And people have done experiments and to see what is the ranges where you can work outdoor activities possible, to what extent, and where it is impossible to do any outdoor activity. And so above 45 is humidex, about 45 is dangerous. So it is almost advisable not to do any outdoor activity. So the problem is that the number of days or number of hours that this can happen in tropics is very large. And that it happens in the extratropics is could be very small relatively. And so therefore, and most of our productive work is outside. Agriculture, construction, mining, everything is outside. And all our, and then the most of our lower middle class people or the workers are all working outside, and therefore their health and productivity is affected by very much affected by this increase in the heat stress. If this is increasing more than 45, and the number of days that if it has increased, then it is really has a very serious impact health-wise, as well as health cost is going to go up, and also productivity will go down. And these people who work outside, if they cannot work, then that their livelihood is affected, because they cannot even. So the whole thing has a serious implications. But I don't think this has been seriously, in our country, nobody has really talked about it. And the policy need to be made, because now I'll show you how much it is increasing. And if that is increasing so much, we need to change policies of adaptation and mitigation of this humid heat stress. So how do we adapt? How we can make people work or save their or minimize their medical cost, and minimize loss of productivity, loss of revenue, whatever their livelihood revenue. So that is a serious problem. So that is why I thought I'll talk about it. And so what we did is that this problem. So the history, as I said, history was that the student started, the high school student started working, but Pralay had prepared some data, and these two students, they're very enterprising students, and I was very happy, and that they could do some calculation by themselves, and was coming up with some of these results. But what we found, so if we took this data, and so we take this basically ERA data. See, I think this can be done much more sort of effectively, because every whole day sometimes doesn't exceed that value, na. So therefore during the day, maybe a few hours it exceeds sometimes, and sometimes it does maybe 1 hour, sometimes maybe 3 hours. So we have to actually calculate how many hours in a particular day, and find out over the season how many hours are lost. So, but that requires actually hourly data. And at Cotton, we could not really do all that, because it is a very huge problem. This is a very good data set, that has the hourly analysis of ERA5 is a huge resource. And that data is now being used, all the AI developers application to the atmosphere, weather and prediction. So therefore now it has become so bad that you can't even download anything from it. Is so much overwhelmed, that site. I don't know if you guys are trying anything, but recently we have found that it is very difficult to download anything from ERA. It's because I know because lot of people are trying to use this data to train some AI models for various applications. And so anyway, so what we could do is that we actually found out, just downloaded the maximum air temperature and humidity, and then calculated the wet bulb temperature, and tried to find out, okay, every day the maximum wet bulb temperature, how many days it exceeded 95 percentile. This is also, it's not related to humidex, it is just extremes in the wet bulb temperature itself. It turns out that they are somewhat related, will be related. So so we calculated that. We did it two different ways. First, sort of you look at. So my hypothesis was that these heat stress are always generally large scale. So if it happens in one of the grid points in the northeast, most of the grid points, most of the regions will feel it. So therefore, if you take an average temperature and humidity data over the region, and still calculate the wet bulb temperature of the average wet bulb temperature, and look at its 95 percentile exceedance, you will find more or less similar thing. Or you can do every grid point, you can look at the data and aggregate, and then divide by number of grid points, then you will still get a more or less same result. Okay, so we did that, and then what we found is, this is very interesting result. See here what we plot. If you plot the total number of days in this season, June, July, August, September, days which exceeded 95 percentile, averaged over this region, just an average time series, very simple. So my students also, the high school students, couldn't do only so much analysis, right? So we restricted ourselves to a very simple problem. And it turned out, see, it's very, up to about 1980, the number of days over the whole season used to be only about 10 days. It exceeded only 10 days. And now it exceeded about 70 days. Almost 7 times it has increased. And that is huge. I think this, I was when I saw this result, I thought maybe there is some mistake. It can't happen. And it happened in 2 decades. So the question is, why did it happen so fast and so only in this? This was a very important science question, and we didn't know the answer to start with, but we're beginning to understand it now. But from practical point of view, and I think my perception was correct in that sense, that I thought that, well, it is increasing. So I started with is just a perception, personal perception. And perceptions can be erroneous. But it turns out the data also shows that indeed it is increasing at a much faster rate. So how is it increasing? Why it is increasing? So we tried to look at, it has to come from the increasing length of dry heat spell days. So we looked at, just looked at Tmax. Tmax, and there, if Tmax exceeds, let us say, how many days, sort of frequency of occurrence, or how many, the frequency of occurrence of 2 days spell, 3 days spell, and 4 days spell, and 5 days spell, and like that events. So how many events are there? So some events we fixed up, and then number of events, those events about increasing 3 day spells have started increasing. Number of events during this. So this, which means that the number of events which are heat spell days, or extreme heat spell events, that have started increasing. And that is why, so it is kind of, it has some relation with dynamics. Now, where does this heat spell days comes from? It essentially are something like a high pressure system sitting in our region. Normally, heat spells are associated with a high pressure that becomes stationary. And that is when there is solar radiation hits up the surface, and because of the descending motion, it kind of becomes an oven. So the surface radiative heating is also there, and there is no cooling, and there is heating from the atmosphere. So atmosphere becomes like an oven, and the temperature, you get a heat spell, and that is. So most of these heat spells are essentially large scale, and they come from some systems becoming stationary. And in those systems, we'll have a high pressure, low pressure, and system. These are some sort of Rossby waves, and those get anchored. And when they get anchored, and they produce these spells, and that number seems to have increased. So that is the preliminary finding. So where was the here?
Yeah.
So let me and that regard us know. So the second question, then we wanted to find out whether it is essentially our problem, or it is only the Northeast problem, or it is a bigger global problem, or India problem. It turns out that we are sitting on this sitting on the sort of center of a big global problem, and that global problem is to do that, actually I am collaborating with IIT Subodh, and because I cannot download this data, and we don't have a computer power to actually analyze the to also. So he is doing most of the work, and we have some preliminary results from there also, and it is coming, and that is really showing something very very interesting. So let me show you what is this. So suppose I have. Can you read this, or can?
Yes, I can. We can read it.
You can read this. And this one is No. Somehow,
Shall I read it out for you?
no, I know. So there is something called, we have defined something called a potential outdoor productivity loss. So what we define it, how we defined it, if it increases, if any point, any grid point. So every hour we look at it, we calculate humidex, and if humidex exceeds 50, so I have taken a sort of more conservative estimate. Suppose even 45 is very similar. In fact, number is very large, but 50 means these are more extreme days, more extreme cases. And in the more extremes, it is like in tropical cyclones, they are the category 3, category 5, and so on. So this is like category 5, and we know that those are the ones which are actually increasing faster, and those extreme. So these the days exceeding humidex 50 are increasing even faster and much faster. And so, and then to that potential loss means see that so many working people are there, the 25 to 50 years age people are work outside, let us say, and we have a population data. So so what brought in population data and also.
Oh, I think we.
Sir, mute হৈ গ'ল নে আমি
No, I think we lost BNG.
but how slide-খন share হৈ আছে তো
Freeze হৈ গ'ল নেকি?
Is it there?
Hello. I'm messaging. মই PNG message কৰি আছো.
Yes. Can sir Reddit আছে, participants still আছে.
নাই. ছাৰৰ ইণ্টাৰনেটে হেৰি হৈ গ'ল নেকি কিবা কাৰণত?
মোবাইল যোৱা নাই?
কাৰণ মই মেছেজ কৰিছো, মেছেজটো ডেলিভাৰ হোৱা নাই. Okay, we stay tuned for some time.
Shall we continue the discussion or?
Yeah, I mean.
But I think I am really interested to hear the কেনেকৈ high school students গোটেইখিনি project.
Oh yes, we got it back. Yeah.
I mean, okay.
Yes,
okay.
you are, sir.
Okay. So I have to. Is the presentation still on or?
No, you have to reshare.
No.
আপুনি আকৌ এবাৰ share কৰি
দিওঁ. Okay, ৰবা মই এইটো
ভিডিঅ'টো অফ আছে.
ভিডিঅ'টো আউট হৈছে. Okay. এইটো কেনেকে হেৰি কৰো আনশ্বেয়াৰ. Okay. So okay. Where is the video?
আপোনাৰ again left bottom mute আৰু stop video টাইপৰ দুটা বাটন আছে.
ৰবা মই ক'ত আছিলো? ভিডিঅ'টো আহিলে. Okay. Share কৰি দিওঁ. Okay.
Yes.
Okay. আপুনি ল্যাপটপত আছে তো?
ল্যাপটপত আছো. ৰবা. এইটো মই সাইন আপ কৰিব নালাগে নহয় জানি এতিয়া?
নাই নালাগে.
নালাগে. আপোনাৰ
প্ৰেজেন্টেশনটো এইটো এতিয়া মই হেৰিটোত কোড শ্বেয়াৰ টু কোড গ'ল.
শ্বেয়াৰ হৈ আছে স্যাৰ.
শ্বেয়াৰ হৈ আছে?
ফটো অন হোৱা নাই?
শ্বেয়াৰ হৈ আছে.
শ্বেয়াৰ হৈ আছে নহয়?
Yes.
এতিয়া মই কি কৰিব লাগে? মোৰ সেইটো ভিডিঅ'টো অন হোৱা নাই নেকি? ভিডিঅ'টো অন হৈ গ'ল. That is okay. ৰবা
প্ৰেজেন্টেশনটো কৰিব পাৰে? PPT টো প্ৰেজেন্টেশন মোডটো
প্রেজেন্টেশন মোডটো কৰিব পাৰো, right?
Yes.
ঠিক আছে, okay, ঠিক আছে, ভিডিঅ'টো পিছত কৰি দিম, it is okay.
Sure. No worries.
Yes.
So fine. So what we found is, so when you do that, calculate this potential productivity loss. So it is in terms of sort of billions of hours, okay. And so what we did is we sorted out the humid heat stress from the dry heat stress. So because we have the humidity data, and so you could sort it out that if the humidex happens when the humidity is less than 25%, then we call it a dry heat stress, dry heat loss or productivity loss. But if it exceeds 25, between 25 and 100%, then we call it a humid heat stress. So it turns out that in India, most of it actually is, we don't have less than 25, very little days where we have very less than 25% humidity, and therefore it is mostly humid heat stress. So therefore it is a misnomer that it is dry. The dry days are very small. So the interesting thing is that this is from 1950 to 2020. The dry heat stress increase is rather mild. It is not very, and it is in sort of billion people hour. But humid heat stress also was not very high, but still, of course, it is larger by one order of magnitude compared to the dry heat stress days. But from 1980s, from about 80s, middle of 80s, this global dry humid heat stress is increasing exponentially almost. And interesting thing is that it is almost half of it comes from India. Almost all of that global heat, it is because our population is high, but also because it is more humid in the monsoon. Okay. And that can be seen. I'll come back to this figure, but let me show you the next figure where you see, this is where the most of the regions, this is 45 only, okay, not the 50. 50 will look similar, but number will be a little bit different. But this is a normalized one. This is not actually the person. This is per person per year, how many hours you can expect to lose. So this is in 1940 to 49, this area and this. What you see is strikingly that it's all over the tropics only. You see, this is only over the tropics. If you go 70 and all that, you don't see, in this scale, you don't see anything. There is nothing. That means the colder regions. So the tropical regions are disproportionately affected by the humid heat stress. And this is a problem created by develop, and all the developing and the least developed countries. Africa, Africa.
So how much of this is related to the fact that your index itself is has some moisture weightage, like?
Oh, it is humid. It is due to the moisture only, mostly due to the moisture, partly due to temperature. I'll come to that, and I'll show you in that figure. So it's partly due to the temperature, global temperature increase, and global temperature increase has associated moisture increase in the atmosphere. Atmosphere is that much moisture content is increased. But this is the humidex is even non-linear, even increasing much more faster than how much temperature it is increase, how much moisture it is increasing in the. That is because it's a non-linear function of evaporation, because the sort of SST increase, and that I'll come back in a minute. So point I want to make here is that it is essentially it is the tropics is much more disproportionately affected by this, and area over which it used to affect in the past and has expanded and increased by manyfold over this. And look at India. India is in the middle of, is the major, and the least developed countries here are getting affected very much. And so China has a lot of population, but China climate is, to the northern part, is colder climate. It is affected by the extratropical climate. So China is, I mean, then their potential productivity loss is much less than Indian. And some of these the Gulf countries are also pretty badly affected. Now let me go back and just so this is the global mean temperature trend, okay, in this period. So the dry heat stress increase is somewhat proportional to the global mean temperature, but not the humid heat stress. This is non-linear, much more non-linear. Question is why? It's partly due to population, because population is I'm multiplying by population. But is the population alone? But so avoid that population, we looked at and normalize the loss, normalize the productivity loss. So per person and so that, or you can do simply forget about population, and if you do how much humidex is increasing, and that will be something like this this curve, which is normalized completely. So so this is again a global picture, and this is India, and India is it is also increased. So in Northeast, it is exactly like this. So the Northeast problem is a part of Indian problem, and it is very similar to. So it is a scientifically also, it is, if you look at Northeast, it is a part of actually a bigger problem and bigger issue. And so I think we need to address that. But if you look at India, Indian, again, the dry heat stress part is more or less of the local temperature, but the humid heat stress increase cannot be explained simply by the increase in temperature. So it is, and that is because of the I don't have a picture here, but that is what I'll tell you what. So let me give a number here. The number of these is this productivity loss, for example, India here. This factor is almost about 80 times. This has happened. The productivity loss has increased by about 80 times the extreme heat stress productivity loss. And but the climate part, if you normalize this factor is I think about 7 or 8. I forget. I have to calculate. I have the number somewhere. But if you see, it has increased from about 5 times maybe. Due to the temperature effect alone, the increase maybe would have happened by about 5 times. But because of the humidity being nonlinear in some sense, because humidity comes from the efficiency of evaporation, and evaporation, as the temperature increases, sea surface temperature also increases, and if sea surface temperature increases beyond a point, and then the evaporation becomes much more, and if the atmosphere can keep that moisture, the moisture content will increase more rapidly, and that seems to be happening in the Indian worm pool region, and in the Indian Ocean and Western Pacific worm pool. If you plot the average temperature between 0 to 20 degrees and about 170 degrees east to about 130 degrees east, that number, it has increased from about 27 degrees to about 27.5 degrees to about 28.5 degrees now. It became about 28 degrees around 80s. So somewhere around 1980s, things had changed. The question is why? This has been we're still working on it, but it is not 100% clear. But we feel that this is another tipping point in the, and look at the way it is increasing. This loss, this productivity loss is also a health cost increase. This is the health cost increase is going to be in this proportion. And if it is exponential in the next 5 years, it is going to be miserable for everybody. And the governments have to recognize it, because you cannot make policy decisions or economic, we are talking about India says it will grow 7%, 8% all this thing. This is not going to allow you to do that, because unless we protect ourselves. Or change, I think we have to change, because part of the mitigation plan should be also control the global warming itself, but we are not doing that. So I think this is a wake-up call, and I feel that there is a tipping point here, and so we are exploring that in a way. So it is interesting, interesting stuff, but there's still a lot to understand, and some things that we have figured out. One interesting thing that we have figured out is there are year-to-year variations of this, and not very small, they're large. Large year-to-year variations. It turns out they are related to El Nino in some sense.
Yeah,
very funny, because globally, but there is some it probably seems to make sense, because the global mean temperature itself has some relationship with El Nino cycle, and so it turns out that I had a figure. I think somehow I missed. I did not put it on. Okay. So actually, if we do, so what we have done is we have calculated.
Okay. You just okay.
Okay.
Yep.
Okay. So
sir, I have a question here. Sorry for the interruption.
You can. We can have questions now. I think.
Yes, দুটা question আছে। বিদ্যুতে সোধাৰ আগতে মই ভাবিছো সোধো, আৰু সেইটো অকমান সম্ভৱ from audience perspective হ'ব। So আপুনি আগৰ স্লাইডখনলৈ যাব নেকি, the previous one? যিখনৰ frequency of hot days আছিলে।
Okay, ৰবা এখন মুভ কৰা নাই।
আপোনাৰ এনিমেশন টাইপৰ আছিলে কাৰণে কৰিব স্যাৰ, আকৌ তাতে ক্লিক কৰক।
Yes. This one. So the first left panel আপোনালোকে plot কৰিছে যে total number of heat spell days, and it is over, the green is for central India, আৰু blue line dal north east India কাৰণে।
Correct.
আৰু ইয়াৰ পৰা আমি দেখিছো যে except in 1980s, in the recent time between 2005 probably and 2024, I guess.
So 2020 jor pura dhara roughly.
Roughly
2020 jor pura about last 2 decades.
Yes.
There is something has happened in the last 2 decades, and that is what we are trying to understand also. Okay, go ahead to my question.
Yes, the more question to hold je, while the green line, jodio variability ase, it is like the variability stays roughly between the 3 events per year, no? But the yellow line, this is like shooting like anything, like beyond around 8 spells. So etu enekwa kotha hoise neki je central India jodio ami hoday gorom boli ko, tetia hole the number of frequency of heat spell days eke ase, kintu basic gorom hoi goise, while north east India basic ghanai gorom poriboloi
So I think what is happening is that actually the amar Tmax too, even though Tmax is different from North India. See, if you look at our annual cycle, normally in central India, their maximum takes place in April and May, or maybe May, early May. So, and there is a big peak, and then when the summer comes and the rainfall comes and the surface cools, and then its surface temperature never goes up. Surface temperature remains cool. So it is like it goes up and then comes down and remains low. But in Northeast, it is not like that. Northeast, it is from May onwards, it is just picks up and then stays like that. That is because there is always rain already from May, and there is already, it is more or less saturated, surface is saturated, and therefore there is not, it cannot cool down further. So, but it remains warm, and that warm temperature is always never very high. So this 40 degrees is an exception, but it cannot go to 45, but our mean is about 30, 33, 34, 30, 35. So 33, 34. So that itself is, and then from there will be plus minus few degrees. That is the maximum is above that mean. That mean standard deviation is maybe a couple of degrees. So maybe কেতিয়াবা তাৰ পৰা গৈ পেলাই 39 হ'ব, কেতিয়াবা হয়তো 40 হ'ব once in a while, but 38, 39. That itself is, so that kind of Tmax tour, hey, 95% exceed কৰাৰ হেৰিটো days বিলাক, তাৰ spell বিলাক increase হৈছে. So that number of spells are increased. So in a way, what is seems to be happening is that our rain spell বিলাক, so আমি সেই break spell বিলাক অলপমান বেছিকে ভালকে study কৰি আছো. Break spell বিলাকত আমাৰ এইটো break spell বিলাকৰ হেৰি বিলাক বাঢ়িছে অলপমান. মানে the active spells are stronger and shorter, but the break spells are bigger, longer, and more frequent. So তেনেকুৱা হৈছে.
Yes.
So I think that adds up to this heat stress problem.
Yes. So overall গৈ পেলাই গোটেই সিজনটোত মানুহে বেছি দিন
গৰমটো feel কৰে.
And sort of next question is regarding the previous slide. The previous one, yes. No, previous আগৰখন. তাৰ ইয়াৰ আগৰখন. No, তাৰ আগৰখন, sorry.
Yeah, oh, Humidex too.
Yes. I think this graph খন আমাৰ মানে অডিয়েন্সৰ কাৰণে self-explanatory, আৰু যিসকলে অলপ মানে awareness আছে তেওঁলোকে probably if they get this graph and then can see. So মই actually মৌচম এপটো চাই আছিলো আৰু তেজপুৰৰ temperature আৰু humidity কথা চাই আছিলো, and it is written that overcast sky and like 100% humidity. Kinto feels like current temperature is like 27 degree around.
Right.
And feels like 32 degrees. So my just
correct.
Yes.
But to me, it's right now. If you do that, you should not look at it during the rainy spell. When there is rain today, it will not make difference, because when there is rain, there is some local surface evaporation, body evaporation. The whole the trees and everywhere there is rain is falling and it is evaporating. So it feels cool. So when there is rain, this doesn't. Only non-rainy days it makes sense. So so these are should not be counted on a rainy days. So basically, mostly they will be effective. So that is why I think it is because last 1 week we have been having continuous rain, so it feels cool actually. Even though it 100% humidity, it doesn't feel bad, because and the temperature is 27 degrees. But 27 degrees and 100% humidity, if I calculate, it will still feel like almost 45 degrees. But it doesn't feel like 45 degrees today. Because rain is cooling down the surroundings, because there is some evaporation going on from various places, and the air is remains cool. So I think that the whole concept of heat stress is on non-rainy days.
Yes.
In
Right.
fact, yeah, that is one thing that we might have to do a little bit of improvement in our calculations. That I don't think we have separated rainy days and non-rainy days. So that also have to be done.
Yeah, that will be actually very interesting to look at, I think. Yeah.
Yes.
So
So sir, পাৰিলে আপোনাৰ ভিডিঅ'টো অন কৰিব পাৰে আৰু I think slide সেইটো নহয় নেকি?
এইটো নহয় মই হেৰিলৈকে যাওঁ নেকি, এস্কেপ কৰোঁ নেকি এইখন?
I
sure.
think can if you do.
Okay.
আৰু আপুনি আপোনাৰ তলত জুমৰ বাটনটো আছে একদম তলত চাওক আপোনাৰ গুগল ক্ৰোম ওলাই আছে
got it মোৰ এই হেৰিটো বাৰডাল কৰবাত গুচি গৈছিলে কি হ'ল unable to start video. Okay, ভিডিঅ'টো কি হ'ল? ভিডিঅ'টো কিবা এটা হৈছে এইটোতো মই you cannot start video because host has stopped it. You cannot start your video because host has stopped it.
Yes sir, please. I'm so sorry.
ক'ত গ'ল আকৌ বাৰডাল?
Yes. Yes, we can see you.
Okay, now
We can see you.
Okay,
Yeah.
okay.
So, I mean, we do not have time, but it's interesting. মানে আমি অসমৰ হিটৱেভ বুলি কৈ পেলাই যেটো আৰম্ভণি কৰিছিলো আৰু যদিও আমি মে মাহৰ ফাৰ্ষ্ট উইকৰ কথা কৈছিলো, but আপোনাৰ যেটো এনালাইসিস দেখুৱালে which appears to be more global and more not restricted only to pre-monsoon months.
Right. So what we have done is actually we have done the whole year.
Yes.
গতিকে anyway যেতিয়া ফিল্টাৰ হৈ যাব, তুমি যদি এপ্ৰিলৰ আগত যোৱা তেতিয়া তোমাৰ হিউমিডিটিটো ইমান কম হ'ব যে then there will be it will not contribute to humidex very much. So therefore we have checked that also. Basically it comes from May to October mostly.
But I think during May আপোনাৰ যেটো heat index আছে, humidex, because it involves humidity, probably humidex is more applicable over northeast during pre-monsoon because of its vegetation. Karan Central India oporot probably, even though globally the atmosphere will hold more moisture with warming, but northeast oporot probably due to vegetation it will recycle more moisture and
more
moisture than Central India. So probably northeast oporot hetu eta heri hobo. And I was also curious regarding northeast oporot apuni jetu oven or heritu kole concept to dile je there is a high pressure and then the surface is warming and then it becomes like an oven. So how much I learned about something called elevation dependent warming because of the topography and northeast or Assam is mostly valley. So he valley to temperature to trap what elevation dependent warming e kiman help koribo, because elevation dependent warming might stabilize the atmosphere further, so which might amplify the oven like situation further. So I do not know keneke hobo, but that's something which came to my mind je elevation dependent warming মানে মই সদায় northeast mountains বুলি কওঁতে I was curious like how elevation dependent warming might have affected the stability of the atmospheric column in northeast.
What do you mean by elevation dependent warming?
So like our atmosphere to jodi freely thanda ho jay, the normal lapse rate. So if we assume normal lapse rate, open field of temperature normally decrease ho go ase with height, but if I have a sloping terrain jot mountain to surface to will be warmer than the air column, I mean layer of air next to it at the same height. And that layer of air gets affected by the warmer surface of the sloping terrain. Then it decreases the lapse rate from its natural value if there was no mountain.
Yeah, I suppose that is possible, but I think in Northeast, I think this problem is that requires a sort of, so on a very large scale, I think it works better. For example, there's a Tibetan plateau and
Yes.
the rest of India. If you
Yes.
think about it, then that gets heated up, or it's the mean temperature itself is surface temperature is higher, and or lower, and then it gets heated up, and this at that level, the lapse rate cools the surrounding temperatures more. Therefore, there is a difference. Now, in the Northeast, the mountains are very, first of all, they're shallow and they're very small scale, very small. So, I don't know how much of that will affect on the regional scale, because there is a lot of variability here. The mountains are very porous, very small. এটা সৰু এটা পিক এটা সিহঁতে তাৰপিছত আকৌ ভেলি এটা আহিছে, আকৌ পিক আহিছে, আকৌ ভেলি আহিছে, তেনেকে গুচি গৈছে নহয় চাৰিওফালে। তো আৰু তো সেইটো কাৰণে আই এম নট চিয়'ৰ that requires probably
Yeah, I mean, me neither. ময়ো sure নহয়, just mountain আছে
very
কাৰণে
high resolution কিবা মডেল লৈ পেলাই তুমি যদি ষ্টাডি কৰিব পাৰা হয়তো তেনেকুৱা হ'ব পাৰে নে নোৱাৰে, বাট আই এম নট কোৱাইট চিয়'ৰ। আৰু সেইবিলাক আৰু বেছিভাগতে ভেজিটেশ্যন আছেতো আমাৰ, গতিকে এটা ভেজিটেশ্যন উইল ইম্পিড ডেট। তো বেছিভাগ মাউণ্টেইনছে ধৰা এতিয়া আমাৰ ইয়াত
ভেজিটেটেড
ভেজিটেটেড, স্পেচিয়েলি নাগালেণ্ডৰ ফালে যদি যাওঁ আমি, অৰুণাচলৰ ফালে যাওঁ, বেছিভাগে highly vegetated. So
another thing, আপুনি যিটো large scale বুলি ক'লে, another small scale variability is urbanization. মানে আজি যদি আপুনি পাটবাউসী ঘূৰি যায় গুৱাহাটীৰ পৰা, তেতিয়াহ'লে আপোনাৰ চাইল্ডহুডৰ পাটবাউসী আৰু গুৱাহাটীৰ মাজত এইটো ডিফাৰেঞ্চ, আজিৰ ডেটতো পাটবাউসী আৰু গুৱাহাটীৰ মাজত সেনেকুৱা ডিফাৰেঞ্চ থাকিব নে আপোনাৰ লাৰ্জ স্কেলৰ ভিতৰত আৰ্বানাইজেশ্যন ইজ গোইং টু প্লে এ কি ৰোল?
Urbanization is definitely going to play a key role. I think urbanization adds up a couple of degrees to the places, and therefore that couple of degrees is going to hold another 14% more more local moisture, na? So therefore so you're having discomfort level is always definitely higher, and discomfort level partly because of the urban heat island increases the mean temperature itself. Overall, over the area that I said at 1.7 degrees or whatever over the last 50-60 years, this much increase has taken place over the average area. But in the urban island, heat island, on that there will be another 1 degree more or 2 degrees more on the locally. So therefore, those. And the problem with the urban microclimate is that there is the dissipation mechanism is very poor. So that is why it feels even worse, because the buildings are close by. There is no enough ventilation. The houses are close by. So when there is humidity and no rain, and during that time, the heat released by the buildings cannot be dissipated properly, and that makes it even more worse. So I think that is those are urban specific problems. Oh, definitely. My village has definitely changed, but I think it is still much better than the urban region. Guwahati definitely well. Guwahati problem to worse lage.
This has like serious implications. Guwahati বা urban area planning লৈ পেলাই, how to handle the human resources.
I think in a later session we can talk about heat island
Yes,
বা
yes.
microclimate তেনেকুৱা অকমান আৰু probably some basic figures লৈ যেনেকে BNG said like how the heat gets dissipated, what does it mean actually এনেকুৱা ধৰণৰ অলপমান simplified way we can have some discussion
Yes.
probably in a
So,
later yeah so but we
yeah, I
are
think
yeah. Yeah.
we are almost
Out of time? Okay.
we have run out of time. I mean, by
Okay.
design, I
Hmm.
mean, by design of my training, I am habituated to listen to you and understand. So, এই session অকমান বেলেগ ধৰণৰ হৈছে normal হোৱাতকৈ
অলপ বেছি technical হয়।
স্পিকাৰে কয় no this
No, no,
session
no.
এই sessionটো এনেকৈ ভাবিছিলোৱে যে আপুনি technical বা science behind it as it আপোনাৰ পৰা আমি শুনিম so but বেলেগ স্পিকাৰ হলে হয়তো মই মাজতে ৰখাই পেলাই সুধাৰ অলপমান বেছি হেৰি হ'ল হয় কিন্তু আজি because my training says that I listen to you so
No, I think you should ask questions.
yes, yes.
If I trained you only to listen, then I have failed.
No, actually what happened, we wanted to have a session probably last year on heat island and all, heat waves over Assam, but that time we couldn't find like proper someone who is actually working on the issue at the time. And we had to navigate in a different way. So then since this time we got to know that you are already started working on this, so that we wanted to know the science behind it. So probably when we will talk about the heat island, that will be more interactive session because now we have a background on it.
Sure.
So, yeah,
This is new to me, and I'm also learning.
Yeah.
So
but we will have that session soon so that we don't
this in addition to the heat index, I think the cost side of it, the time loss per person, plus I don't know, apuni jodi etu sessioner pisat school student or application aru basic hoy pai, but this was really encouraging to see the school student apnar logot kaam koribo ahise, and as scientists
and
in India, I think this is also something we can learn from you, that we can address a problem working together with school students.
Yeah, I think they had interest. So I think we need that interested students. So if student is interested and willing to work a little hard, then they can learn. And they got also excited. And they both of them got admission into some undergraduate, some university in USA with some scholarship. So they have real aim doing something.
We will learn about that as well. So
this is a nice note to finish today's session.
Thank you.
So thank you again.
Okay. Good to see you guys. Take care. And we'll see you in July.
Yes, we'll see you in July.
Duita ahibane?
Na moi goi asu.
Sir, etu session to end koru. Ami thank you note, and then let's have a like 5 minutes discussion probably.
Okay.
Yeah, thank you সকলকে ধন্যবাদ আমাৰ সেশনটো চোৱাৰ কাৰণে, and this is the first time we are doing in YouTube, গতিকে ভিডিওটো থাকিব যোনে চাব বিচাৰে। Sir, thank you. Vidyut, thank you for hosting the session. Thank you Anajori for giving us Zoom, YouTube, Facebook, everything, all the platforms, and see you all again in the next month.